variables. So this is using functions, but with word problems. So let's have a look at this. Two variables are linearly related if the graph connecting them is a straight line. Can you please write that down and pause the video now? Welcome back. So let's go over this problem. Ted, the taxi driver, charges passenger an initial fee of £4 and then £2 for each kilometre travelled. So the initial fee is always going to be 2, regardless of how far they have travelled. I should have actually said 4 then. So the initial fee is always going to be 4 plus an additional 2 for every single kilometre. So that's why it starts off at 4, and then for each additional kilometre we are going to add 2 onto the previous one. We now need to study the relationship between both of these variables. We know that the cost is dependent on distance travelled. This means that they rely on each other to find the other answer. If you plotted the graph, we would find the following. It's linearly related. This is because each of these points fall on a straight line. The c-intercept is 4. This always represents the cost, or the initial cost, without going anywhere, if this problem is to do with a taxi. The gradient is 2, which is the cost per kilometre, and we know this because this is the difference in y, which is 2, divided by the difference in x, which is 1. We could change our triangle, so we could be looking at a bigger triangle, and this would still work. We could work out the difference in y being 4 divided by the difference in x, which is 2. 4 divided by 2 is also going to give us a gradient of 2. This means we can write the following equation. C equals 2d plus 4, where C represents the cost, D represents the distance, and 2 is the gradient and 4 is the intercept. Very straightforward, like y equals mx plus c, but replacing y and x with c and d. So if we wanted to find, for example, the cost of a 10-kilometre journey, we could use the graph. We would continue on, and what you would do is you draw a line up from 10, and then you'd have a look across to the value for C. So if we were doing this for, say, a 2-kilometre journey, this is much easier. We would just go up from 2 and then across to 8. So we know that the cost is going to be £8 for a journey of 2 kilometres. Another way of doing this is by using substitution. Because we know that the distance is 10, we just replace D with 10 and we get the cost to be 24. So in this situation, it's clearly quite exact. However, other things don't have exact relationships and more or less have a linear trend, which means even though they're not exact, they do still follow a straight line, but not exactly. So this is an example which is not an exact model. So we could be given this table in an exam and asked to plot these points, and then we'd have to plot this straight line. Have a think and pause the video as to why we would plot the straight line like this. Welcome back. Hopefully you noticed there was a similar number of points above the line and below the line. We have 1, 2, 3 points above the line and 2 below. It's difficult to get exact number, but 3 and 2 is quite a good comparison. Again, for this model, we could be asked the question, if we have a cost of 200, what time does this represent? So you would find the cost of 200, which is this time is in the C or Y axis. You'd go across to the line itself, and then you would go down. So we know that a cost of 200 represents the time of 25 as it goes down to this 25 here. This is a really key final point to make. With a linear trend model, when we don't know the exact answer, we can do this thing called extrapolation. So we can guess, using what we think the equation of this straight line is, to find out what we think it's going to be on the 100th day. However, we don't know this exactly. So this assumes a linear trend, but it will not necessarily give us the exact answer. So it's going to be approximately 650 customers, because for this graph, we are going to say that the gradient will be 6, the y-intercept's 5. So taking all of this into consideration, we have the equation C equals 6t plus 50, and we are just going to simply replace our t, which represents time in this instance, with 100. If you replace it with 100, we're going to get 650 customers. I'm going to go over a few questions, and then I'd like you to continue with these questions in your book, uploading them to ManageBack. We're going to go over question number 4. Someone planted a 30 centimetre high bamboo plant in her garden bed. She found that with consistent weather, it grew 10 centimetres every day. So we need to copy and complete the table. So because it started at 30 centimetres, we need to write 30 centimetres here. And what we will do is we will increase this by 10 centimetres every day. So let's do that now. This would obviously go to 40, then we would have 50, 60, 70 and 80 as follows. Then we'd have to draw the graph of h against t. Now if you are drawing a brief sketch, don't worry so much about the dimensions, but you need to work out whether it's asking you to draw a sketch or not in the exam. So I'm going to just draw a sketch, which means it's not going to have exact measurements. We know that the first coordinate is going to be 0, 30. So we would draw the first coordinate here, and then it's going to go up 10 each time. So I would make sure I plot each of these coordinates. 0, 30 would be the first one, then 140 would be the second one, and then eventually you're going to find that you have a straight line like this. It's going to have a positive gradient because the plant is growing, and it's going to have a positive y-intercept because it starts at a particular length which is not 0. Discuss whether it's reasonable to continue the line for t is less than 0 for t is greater than 6 days. Hence state the domain and range of this function. So for this you would discuss that obviously you can't have a negative time, so this bit wouldn't be possible. Now for t greater than 6 days, well, there's a couple of arguments for this. You could say yes, it could grow, continue growing with this pattern, but at some point a bamboo plant is going to stop. So we're going to assume that beyond 6, perhaps we don't know what's going to happen. So the domain are the values of x. The values of x are going to be t in this instance. That's going to be between 0 and 6. So we say the domain is between 0 and 6. I would write 0, an x, and then a 6. And then we're going to say it's going to include 0 and include 6 itself. So we're going to put the inequality with a line underneath, which means less than or equal to, or greater than or equal to, depending on which side of the inequality you're looking at. That is going to be what we call the domain. Now the range is going to be the difference in the y's. Now we could argue that rather than writing x, we should really write t, because for the domain, the x-axis in this instance is actually t. Now let's have a look at the range. The range is going to be the difference between the minimum y value, which in this instance is h, which is 30, and the maximum, which would be 90. So taking those two values together, we're going to have 30 h, and then we're going to finally have 90. So this is just effectively substitution. So this should be quite easy. Find the model connecting h and t. Now I believe the best thing to do for this would be to write down the straight line equation. So we know the gradient is what it's jumping up in each time, and we know the y-intercept is going to be 30. So our model would be the following. H equals, then we need to write down the gradient. Well, the gradient is 10. So 10t, because that's what it's jumping up in, plus, and then the y-intercept. Ironically, the y-intercept is going to be this number as well. So I'm just going to move this answer here. So our answer is h equals 10t plus 30. How long will it be for the bamboo to be 1 metre high? So we can see it's 90 centimetres high here, so it would be 1 metre high after 7 days. So that will be our answer for this. So what I'd like you to do now is continue with these questions. There's questions 1 through to 6. We're then going to finally go over a piecewise model. A piecewise model is when it's made up of several different line segments. You can pause this and read this if you'd find it beneficial. So we're going to say, initially we get a base rate, and then once we go beyond that base rate, we have a higher rate. This might be like to do with a mobile phone tariff. Perhaps you get a base rate up to a certain amount, and then beyond that, it might be higher or lower, depending whether that's within your contract. So let's have a look at this question and the answer. Find the gradient of A, B, B, C. Find the cost of 60. How many costs can be printed for 74? A, B, and B, C. This is work we've done before. All you need to do is find the gradient of each of them. Let's have a look at that. So the gradient of AB is going to be the difference in y divided by x. The difference in y is 50 for this triangle, divided by 100. So our gradient is going to be 50 divided by 100, which is 0.5 or 1/2. Then, if we would have to look at the gradient of BC, I'm going to draw the triangle above, but you don't need to. We're going to have 3 as in the difference in y, and then the difference in x is going to be 5. So our gradient for this one is going to be 3/5. Nice and simple, hopefully. So 0.5, and then this one, they actually wrote their answer slightly differently. Let's see if we agree with that. So we said we were going to move 3 down and 5 across. Well, I've made a mistake there. Have a little think and pause the video of how I made a mistake in that part of the video. Welcome back. Hopefully you notice, and this is a really common mistake, and I did this on purpose. People sometimes count the squares, and actually what you should do is count how they correspond to the y and the x axes. So this is going to be a difference of actually 80 to 50, which is 30. Whereas this is a difference of 100. So they're not equal in terms of their numbers, the x and the y axes. So 30 divided by 100 is clearly going to be 0.3, which is why we do get 0.3 for the BC gradient. So be careful with that. Last part is to work out for $30 how much invitations can you have. Well, you just go along from 30 and down, which is 60 invitations, and for 180 invitations we find 180 invitations, we go up and across, and there's going to be approximately 74. In the exam you would get marks for 72 to 74, or 5 for example. So let's have a look at these questions. I'd like you to have a go at these questions and upload your work on ManageBot as well. Best of luck.